In the last several videos, we've talked about different ways of implementing the set and map abstract data types, binary search trees, hash tables, that sort of thing. In this video, and in fact in this lecture, we're going to talk about a totally new abstract data type you may have never seen before, known as a priority queue, and later we'll talk about its implementations. So what is a priority queue? You can think of it as like a bag of stuff or a sack of things, and you can put stuff in it, you can take stuff back out, you can look inside the bag, but what's special is that this sack, it only lets you interact with the smallest thing at any given time. And with that constraint, we'll actually get better performance than we would out of some other more complex data structure like a list or a set. So maybe as a visual example, this sock, I will just kind of show off the operations you can have here. This add operation here, you can think of it as you take, let's just pick some garbage up from this table. Here's my zip card, so I'll put that in there. I've added it, okay, and then I'll grab this kind bar, goes in here. Screwdriver, that's probably good enough, right? Okay, so now I have 3 items in the sack, and so if I say, what's the size? It should say 3. Okay, good. Now if I try to get back the smallest thing, I say, hey, what's the smallest item? I say get smallest, and it will return for me a reference. Oh dear, where is that little thing? Here we go. It'll return a reference to the zip card. Now if I say remove smallest, it actually gives me the reference to the zip card, and it's no longer in the bag. I call remove smallest again, and now I get kind bar. And then finally, I'll do remove smallest using the power. Jeez. Okay, screwdrivers and socks don't get along well. We do remove smallest, and that's the last thing. Now the size is 0. So that's basically what a priority queue is, and it's really handy for keeping track of the smallest, largest, best, whatever else thing so far. So let's imagine that you're part of, let's say, just as an example of why this might be useful, the Grand Leader's Information Compliance and Happiness Enhancement Team, okay? So you're deep in the bowels of the earth, trying to make sure that your citizens are not having any kind of unharmonious conversations with each other using texts. So your job is, each day, you prepare a report of the M messages that seem most unharmonious, using a harmoniousness comparator that takes 2 strings and says which one seems less harmonious. So the naive approach is just to create a list of all messages sent over the entire day, all text messages, sort it using your comparator, and then return the M messages that are largest. And so this is not using a priority queue. What the code might look like is as follows. So we have an unharmonious texts method. We give it a sniffer, which listens in on text messages and the number of messages we want for our report, right? This number. So one way to do it, we create a list of all messages we see all day. We set up a timer, and this is just kind of pseudocode. I mean, the exact details don't matter here, just the story. As the timer is running, we wait 24 hours, and as the day goes on, we just add every message that we see. We add every message that we see using our sniffer, and then after we've created this big old list after 24 hours, then we will create a comparator, which is for comparing the harmoniousness of strings. We will then sort all of our messages using this comparator, and we'll tell the sorting algorithm to do it in the reverse order. And again, the exact calls here don't make much, they're not important. I don't expect you to know what these mean exactly off the top of your head. But the story is, I'm then able to sort all of them, and then I'll return the first M messages from the list, which will be the largest. So this approach will work fine, but the problem is that it might use it will use quite a lot of memory. It could be, it will be theta n, where n is the number of texts, and if a lot of messages get sent in a given day, that's potentially quite a lot, right? So if n is big and we're using theta n memory, we're using a lot of memory. So now your goal is to try and do this in theta m time using a priority queue. And how that's going to work is you will create a priority queue of unharmonious text, let's say, and we'll set it up like this. So this is just going to be some specific implementation we'll talk about later. And I'll let you try and think about what this code looks like. Now, I don't encourage you to sit there and write Java code. Maybe just sit down with a pencil and paper and write some pseudocode and see if you could figure out what the trick is here. Because it's actually a pretty interesting puzzle, and I'll reveal it in a moment. Okay? So I will stop here and let you check me out in the next video where I'll spoil it.